Find the x-intercepts of the graph of the function without graphing the function. The function we're looking at is f of x equals square root of x plus 11 minus square root of x minus 1. So this has some radicals within the equation. So we're going to have to use some techniques to get rid of the radicals to find the x-intercepts. So when we're looking for x-intercepts, we're going to let y equal 0. Now we don't have a y in our equation, but we remember that f of x is the same thing as y. So we're going to set f of x equal to 0 to find that x-intercept. So if we do that, we'll have the equation 0 equals the square root of x plus 11 minus the square root of x minus 11. So to solve an equation like this, we need to isolate the radical and then get rid of the radical by doing the opposite. So these are square roots. To get rid of a square root, you square. So I'm going to start by isolating this radical right here, the square root of x plus 11, and I'll do that by adding square root of x and adding 1 to the other side. So I'm going to add square root of x and add 1, and that means I have this radical here isolated on the right, and on the left I have square root of x plus 1. Now once you have it isolated, you're going to get rid of that radical by doing the opposite. The opposite of a square root is a square. So I'm going to square the left-hand side and square the right-hand side. So on the right-hand side, the square and the square root are right next to each other. There are no other operations between them, so those are going to cancel out, the square and the square root. So on the right, I'm going to be left with x plus 11. However, on the left, the square and the square root are kind of separated by this addition, so those operations don't cancel out like on the right-hand side. We actually have to work out the multiplication of squaring. So we're going to write this as square root of x plus 1 times square root of x plus 1. So that's what squaring means. Multiply that base twice. And let's continue the problem up here. So I'm going to start multiplying. We multiply these first two together. Square root of x times square root of x. We multiply the outside two together. That will be square root of x times 1. Then we're going to multiply the inside two together. That's square root of x times 1. And then we'll multiply the last two together, 1 times 1. And that's a plus 1 times 1. So square root of x times square root of x will be square root of x squared. Let me get rid of that. And I just forgot to write this whole right-hand side of the equation down. So let me write that down. Equals x plus 11. So square root of x times square root of x is square root of x squared. Square root of x times 1 is square root of x. Square root of x times 1 is square root of x, and 1 times 1 is 1. Square root of x squared is x. And then these two terms are like terms. They can be combined together. So what we do is we use the coefficient here is a 1. The coefficient here is a 1. 1 plus 1 is 2. That's 2 square root of x plus 1 equals x plus 11. And now what we want to do is recognize that there is still a radical in our problem. So remember what we did here, we got rid of this radical by squaring both sides. We have to do that process over again. So we're going to isolate that radical and then square both sides to get rid of it. So I'm going to subtract 1 on both sides, subtract x on both sides. That leaves me with 2 square root of x on the left and 10 on the right. I still want to isolate that radical, so I'm going to divide by 2. That gives square root of x equals 5. And then I'm going to get rid of that radical by squaring both sides. The square root and the square cancel each other out, giving you x. And we have 5 squared on the right, which is 25. Now, we have one more thing to do here. Whenever in a problem we do this step right here, we square both sides, and we did it twice. We did it here as well. Anytime you square both sides to solve a problem, you must check your work. And that's because when you square both sides, sometimes you get what's called extraneous solutions. Those are extra solutions that don't work in the original problem. So we need to check if 25 works in our original equation. So I'm checking to see if it works in this original equation here. So that's 0 equals square root of 25 plus 11 minus square root of 25 minus 1. So 25 plus 11 is 36, so we have square root of 36. Square root of 25 is 5. Square root of 36 is 6. And negative 5 and negative 1 combine to be negative 6, and that does equal 0. So our solution of 25 does work, and that will be our x-intercept. 25, 0. So let me zoom out so you can see everything. And we have our x-intercept at 25, 0. We want to use the graph of y equals f of x to answer the question, for what values of x is f of x less than or equal to 0? So on our picture, we have a graph. This graph is labeled y equals f of x, and that is this picture here. So the question that we want to ask or answer is, for what values of x is f of x less than or equal to 0? So let's make sure we know what those symbols mean. F of x less than or equal to 0. F of x is the same thing as y. So this statement is saying y is less than or equal to 0. So let's reword our question with that information. For what values of x is y less than or equal to 0? So in order to answer that question, we need to identify on the graph when y is less than or equal to 0. So let's do that. So remember, y has a scale, which is the y-axis. So this vertical axis is our y scale. And we want to think about, how do we normally label that y-axis? We label right here the origin as 0, 0. So y is 0 right here. And then if we go up, we count up 1, 2, 3, 4, and so on. And then if we go down from that origin, we count negative 1, negative 2, negative 3, and negative 4, and so on. So when we think about the y scale, let me highlight. I'm going to highlight in some different colors. So when we look above the x-axis, everything above the x-axis will have a y value that is positive. So everything above has y being greater than 0, or we can think of it as f of x being greater than 0. And then everything below the x-axis on our y scale will be negative, and that is less than 0. So y will be less than 0, or we can say f of x is less than 0. And let's see, let's use green. Right on top of the x-axis, that is when y is equal to 0, or f of x is equal to 0. So when we're looking for y to be less than or equal to 0, that's going to be any points that are on top of the x-axis or below the x-axis. So let me get one more color here, and I'm going to highlight the portions of the graph that fit our description here of f of x being less than or equal to 0, or y being less than or equal to 0. So this open circle means that point is not on the graph, so that point wouldn't qualify. This entire portion of the line is below the x-axis, so it fits the description. And then we have this point that is on the x-axis, that fits the description. Here we have another point on the x-axis, and then we have all of this part of the graph is below, so y is less than 0 for all of these points. This point is on the x-axis, that's y equal to 0. And this point is on the x-axis, that is y equal to 0. So in blue there, you see all of the points on the graph that satisfy our description here. Now what we have to answer is, what are those x values? So we need to describe those x values. We're going to describe the x values using interval notation and set notation. So I want to describe this interval here as x's. The starting x is negative 11. The ending x is negative 21 over 2. So that's one interval of x's, negative 11 to negative 21 over 2. And with interval notation, we need to decide whether we're using a parenthesis or a bracket. And remember the meaning of the parenthesis and the bracket. The parenthesis means that that number is not included in the set, and the bracket means that it is. So remember, this one had an open circle, and this one has a closed circle. So we're going to include the closed circle. So we're going to put a bracket on the negative 21 over 2, but a parenthesis on the negative 11. So then we want to describe this interval. This interval, it's pretty long. It's going to start with an x of negative 7 and stop with an x of negative 2. So negative 7 to negative 2. Both of those have closed circles, so we'll use brackets on both of them. And we're going to use the union symbol between these two. And we have one more point to include, and that's this point right here. Now this one is different than the others. This is an individual point instead of an interval of points. And so instead of using interval notation, we're going to use set notation. And set notation, we use the curly braces. And we're going to put that 6 in the curly braces. So these are all the x's where y is less than or equal to 0. Okay, and I've just been reminded that this 2 is a positive 2, so we're going to make that correction. This 2 should be a positive 2. And I'll go ahead and erase that negative sign. And now we have our x's being from negative 11 to negative 21 over 2, where negative 11 is not included, negative 21 over 2 is, union with negative 7 to 2, both included, union with 6. So we just got asked a really good question, and we're going to add this in here for what values of x is f of x greater than or equal to 0. So if we're looking for f of x to be greater than or equal to 0, let me highlight that for you. Greater than or equal to 0 would include the points that are on the x-axis, so these same points here, but it would also include any portions of the line that are above the x-axis. So we have two intervals of numbers, and for these numbers would start with an x of negative 21 over 2 and end with negative 7. And we would use brackets because of those numbers being on the x-axis. And then for this interval here, it would start with negative 2 and end with 6, both with brackets. And we would union those sets together. So we have negative 21 over 2 to negative 7, union with 2 to 6. Thank you for checking out my videos. Have a great day.